Well, greetings everyone. This is lesson number 16. I'm Lee, Trigonometry for Students and Surveyors. We're going to do some inversing. That's basically pulling from one coordinate to another coordinate, just like we did the very last lesson on lesson 15. Lesson 15, we pulled coordinates around the perimeter, around our traverse. Now we're going to show you, I mentioned you can cut across, you can met any coordinate to any other coordinate. Very handy to have things you need to do. So I've got these lines here and we'll go through them one by one, but we're going to make some more. This is that same drawing we've been using for the last week or two, the last few lessons. This was a traverse and we've started from turning angles, changing bearings to azimuth, azimuth to bearings, azimuths to converting those to angles, back azimuth, adding the angle to get the foresight angle or a foresight bearing, foresight azimuth. We've been doing everything with this. Now we're doing coordinates. So we'll go through this. If you haven't watched the last one, watch the last episode. Watch lesson 15. It'll explain a lot of the stuff I'm going to explain here. Because I'm just that way. I'm just going to go over a little more briefly right now. Let's start with this information right here. Because we're using zenith angles, 0 is at the top at the zenith. The nadir is the bottom. It's the opposite of the Cartesian coordinates. Cartesian coordinates, where 0 is the x factor is on the horizontal, and the vertical is the y factor. This is just the opposite of that. But this is how a compass is. 360, 0 is at the top. And same with when we measure elevation, it's the same thing. Straight up would be 0. 90 degrees would be due flat, would be straight. And on the other one, 0 is straight. So that's why we want to associate cosine with latitude and northing. Northing is cosine, is latitude, and northing and easting, and I've said this before, it's the same as latitude and longitude. It's just in the surveying we take a smaller grid size and we call it northing and easting. They can convert back and forth as well. So anyway, so northing is cosine, is latitude, easting is sine, is departure, and this holds true if you're referring to zenith angles. Z stands for zenith, and this is a survey symbol. Whenever you write on a stake or in your book, you want to abbreviate the word angle. It's the angle with a little and that's it. So let's start. Then there's a few rules of thumb you'll have to follow here. We're going to do an inverse from 6 to 4. We're going to go from 6 to 4, and then with that, I got little notes here I put in here. So we're going to the northeast quad. Now, if you look at each angle point, I put a north, south, east, and west. And if you're using your graph paper, your grid paper, no matter what angle you come at, wherever your coordinate is, you still have to obey the north, south, east, west. Okay, that'll become clear. So we're going to go into the northeast quadrant. So we do not add an angle. And that'll become clear in a minute. That should be clear if you watch the last episode. Okay, so how you basically do that is you subtract the northing from the northing. We're subtracting the northing from 6 from the northing of 4. We're subtracting, and that's the way we're going, so that's the ones that have to be on top. The 6 has to be above the 4. 6 minus 4 is a negative 18,320. Why is it negative? We're going in a positive direction. We're going up, but we're starting with a lower number than a higher number, so you're going to get a lower number. Now, I mentioned before, don't add or subtract these, or don't take these off or put them on. Just leave them on there. It's a negative 1830 or 881320, and I've stored that. I can store it anywhere. I can store it in A, B, C. I store it in key number 7. That's what that means. If it's a square box, that represents the key. The circles represent the angles that we're making pulls to or making inverses to. Okay, so we got a negative 881320. I'm going to go ahead and put that in there. 88.1320, and add the negative to that because it needs to be there. And I'm going to store that as 7. And I'm going to recall. I always like to recall to make sure I got it in right. And now your next, when you're easting, you subtract your easting from your easting. And we got 1188.0425. And that's a negative. And we'll store that as 3. That's stored in 3. That's this key here. I just like, because what the northing the northing is up, the 3 is the easting is to the east, my theta angle is 0, and then my decimal angle I store as 1. That's what these are here. Okay, so your formula is departure over latitude. Departure is your easting over latitude. So what we're getting here is 13. So if you do, so now once you get those in, and as long as you use your memory, you just recall 3. Actually, 3 is the last one you would have solved, so that'll just be there. So then you just need to recall 7. Recall 7, and then you hit divide. You got 134803. And now you want the arc tangent of that. 85, 75, 74. That's the decimal azimuth, and that converts to 85, 47, 27. That's what that bearing is. That's what that, I say those juxtapose all the time. Bearing and azimuth, that's what that is. If you're going to the northeast quadrant, bearing and azimuth are the same. They're just written a little different, but they're the same. 0 to 90 is exactly the same. So you have that. So that's the bearing, and now we have to figure out the distance. So what we're having is a hypotenuse of a right triangle. This triangle goes 88 feet up and 1188 feet over to here. So we would have a triangle that looks like that. So now we want to get the cosine. So we've stored this decimal in 1. So we're going to go, let me see, did I do that? 85.7574 and store 1. 85.7574. Now we want to hit the cosine of that. And we want to hit the so here's your keys over here. So 1 is the cosine. That's where I've stored this. Once I solved that, I stored it as 1. So that square 1 is the cosine of that. And then you want to do 1x because you're solving for the hypotenuse. You either got to do it in a division and put the distance in first and then the angle, and then hit divide. If you want to just keep multiplying all these different ones, just hit 1x. It's the same thing. It just divides it. So it inverses it. So 1x, and then we want to recall 7 is our cosine distance, and then times. And that's the answer there. So let me try that again. Recall 1, cosine 1x, recall 7 times 119.13069. We solve the hypotenuse using cosine. That would be this one and the hypotenuse. So now we're going to use sine. So we're going to go recall that angle again. 1, hit 1, recall this angle. Now hit sine. And now we hit 1x again. And then recall 3, because that's the easting. And then times 119.13070. Well, I got 3070 this time, it's 69. That's probably because when I stored this, I just added this from there. This is what happens. I was talking about this earlier. If you solve all this and store that, you're going to have the extra decimals in here. This time I just copied my own numbers and stopped it at 4 decimals, so that when I got my answer, it's 3070, it's 3069. It's probably 3069.95 something something. So this one rounded it off. And of course the other way to do that is a squared plus b squared c squared is the other way to get the distance. All right, so we'll just keep moving on here. Let's go to 6, 2, 6, angle 6 to angle 2. Here's 6 up here. Here's 2 down here. So I draw these north, south, east, west here so you can see what quadrant we're going in. Then I wrote it down going into the southeast quadrant. Now, if you remember your sine, cosine, all those things, positive, positive. This would be a negative northing, positive easting. So here's our formula here. I'm going to sit down and do this. So here's your subtraction. The northing from 6, northing 6, northing east, subtract 966, 1438. And that's stored as 7. And over here we have the northing for the easting for 6, the easting for 2, and I guess I didn't write that down there. Let's just do that. The easting for that angle 2, and then that's the answer there. So now you take departure, and I stored that in 7, stored that in 3. You take the departure, which is this one here. This is why I wrote departure. Your easting is departure, and your easting is sine. So your departure over your latitude is 0.9542. You want the arc tangent of that, because remember, we're doing, these are just right angles. We got the two sides of a right triangle. The arc tangent of that is a negative 43, 65, 66. Now you want to add 180 to that. Remember, we're going to southeast quad. We want to add 180. So I'll do a reminder again. A few lessons back, we talked about changing bearing to azimuth and azimuth to bearing. If you're in the northeast quadrant, you don't change anything. If you're in the southeast quadrant, you use 180. So you're 0 and 360, you go to 90, and in azimuth you come down to 180. In bearing, you come back down to 0. So when you're solving these two quadrants, converting them back and forth from bearing to azimuth, you use 180 as your plus or minus, and then you just have to figure out how to do that. We already did that. If you're in the northwest quadrant, you use 360. What you don't use is the two east-west ones. You don't use the 90, and you don't use the 270 over here. You just, or the other 90 if you're going back the other way. You disregard those when you're converting. Same with this. Okay, now I'm lost. Okay, so we have our bearing. Our arc tangent is negative 4365. We've added 180 degrees to that. So we've added 180 to a negative to 180, so it's going to be less, and of course it is going to be less, because 180 would be down here, we're over here, and our answer is 136. That should be a period, that should be a decimal, not a dash. 136, 34, 34, and that is our decimal angle, or decimal azimuth. And so if you ever wanted to convert that to bearing, you just subtract 180 and you get your bearing on that. That's that'd be your southeast bearing if you subtracted 180 from that. Okay, now we want we store that. If you convert that to degrees, minutes, seconds, that's 136, 20, 36. Now we've stored that as 1, and we already have these two sums stored as 7 and 3. So we want to recall 1. Recall 1 is this guy here. That's our angle. That's our bearing. Let me try one more time. That's our azimuth. Recall that. You want to hit the cosine of that, because we're going to solve for latitude first. You want to 1x that to inverse it. Recall 7, which is your cosine, or your northing, and it's your northing, and then multiply that, and that's your answer there. That's the distance between 6 and 2. Now, if you want to find out the other way to check, is recall 1 again. That's your azimuth. Sine of that, 1x that, times 3, which is your latitude, is your departure, your easting, and you're going to get the same answer. So now we have that one done. Okay, now we want to go, so that was southeast. Now we're going to go southwest. Okay, here we are over here. We're going to go from 5 to 1. So we're going to go to the south from the northeast quadrant to the southwest quadrant. So we're going to do the same thing I said over there. We're going to add 180, just like when we converted. We're going to add 180 to the bearing, to the azimuth. So we subtract, and now this coordinate was 5,000, 5,000. That was the one we started out when we did our traverse, and we traversed around here, and we did our bearing and direction and established our coordinates to start with. So we've kind of hit this polygon pretty darn hard every which way we probably could, except for elevations and zenith. That's for another day, another drawing. So we have the northing of, what are we inversing? 5. That's way up there. We have the northing is this number, 66497507. The northing down here is 5,000. There's our, so we subtracted 66649 minus 5,000 is 16497507. Again, that's a positive number because we're going from a higher number to a lower number, even though you're going in a negative direction. So don't be confused on that. Same over here, we have easting, 56347157 minus 5,000 is 6347157. So we have our northing again stored in 7 because that's our north key on the easy north key to find there. We have our easting over here. So this would be equal to the latitude. This would be equal to the departure. We want the departure over the latitude, and that's our fraction, that's our percentage. We want the arctangent of that percentage. Now that's 21 degrees 0434. That's the decimal. Now we're going to add 180 to that. And then our answer is 201.0436. That's the decimal degrees. And we're going to store that as 1. I guess I didn't write that down. So we're going to store that as 1. And this will be 0. I put the finished product as 0. Okay, so we're going to recall 1. I guess I forgot that over here. 1 cosine. 1 cosine. So recall that, hit the cosine of that, 1x that, and then recall 7, which is that number. And then that's what you're going to get is your distance. That's your distance from 5 to 1, 1,767.6372 feet, U.S. survey feet. Or you could be using centimeters, meters, it's whatever you wanted to do. Now the same thing, you recall 1, which is our angle, which is our decimal azimuth. Sine of that, 1x that to inverse the function. 3. Now you're recalling your easting, your departure, and you're multiplying that, and you're going to get the same answer. It's the same distance. Yeah, because we already did the 180. Okay, so we have the bearing and we have the distance, so that one's solved. And the last one is 2 to 6. This is angle 2. This is angle 6. And that's going to be the northwest quad. So we're going to add 360 when we're all done getting our bearings. So our northing for 2 is 5348, 5397. Our northing for 6, 6314, 6835. Minus that, and we get a negative 9661438. We store that under 7. Store it whatever you want, but just make sure you write down what key you store it under. You can go, when you go to store, you can have alpha, and you can store it way up here if you want. Anywhere you want, that's all those are. I don't want you to get you confused and think I'm storing and adding 7 to the store or adding 3. We're not doing that. If it's got the little square box on my drawings here, it just means that's the key I'm storing it under. Your easting for 2, where are we doing 2 to 6? Your easting for 2 down here is 5753.2729, and that's your departure. Your easting up at 6 is 48314046, and so that's a 921.8683, and so I stored that as 3, where I always store my easting. That's 3. Now you want departure. This is the departure. This is the latitude. I guess I can write that. L-A-T D-E-P. Departure over the latitude. So this would be 921.8683 divided by 966.483. And that's your ratio, 0.9542. You want the arc tangent of that is a negative 43.6566. Add 360 degrees to that. You're adding 360 to a negative number. You're coming up with 316.3434. And I stored that as 1. That's the decimal azimuth from 2 to 6. Oh yeah, so we're going, that's right, we're going northwest. That's the decimal azimuth from 2 to 6. All the way up would be 360. All the way that way would be 270. Yeah, that seems pretty good. Then I converted it to hours, minutes, seconds, degrees, minutes, seconds. Stored that as 0. That's the finished product. That's the finished azimuth. But now we want this to find out our distance. So we just recall 1 cosine, and then take the 1x of that, then recall our northing, because we're using cosine and northings are the same. And we come up with recall 7 and 1335.3932. We recall that again, number 1, take the sine of that number, or of that azimuth, 1x that, and times, or recall 3, which is our easting distance, and that answer is 1335.3932. So we've inversed every corner, we've traversed, it's all, I think we're going to put this polygon to rest for now and go to something else for the next lesson. But there it is. Take a screenshot if you need to. Hope that's not too confusing. Anyways, I try to be redundant and repeat things as I go along. So go back to the last lesson if you need to, and so on and so forth. That is that. So please like and subscribe, and thank you for watching, and I hope you get something good out of this.